questions 1 through 10 on the 2002 grade 12 AMC 12B. The arithmetic mean of the 9 numbers in the set is a 9-digit number m, all of whose digits are distinct. The number m does not contain the digit. So how do you take the mean of a set of numbers? Well, as I'm sure you know, you add them all up and you divide by the number of integers or digits or whatever. So we have, I think, 999, all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 numbers here. So you divide by that, and that gives you the arithmetic mean. So they're saying that this number m, whatever it is, does not contain which digit? Okay, so we first have to figure out what m is. So the first thing I'm going to do is factor out a 9. That will allow me to cancel out the 9 in the denominator. And at the very end, that's going to be 9 ones, like this. All right, and top and bottom cancel, and all we're left with is just 1 plus 1, 1 plus 1, 1, 1, all the way up to the largest number, which is 9 ones. And then this is a little bit easier to add. You can easily do this, and you'll get a sum of 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what m is equal to. And they're asking, what digit does m not contain? Well, it doesn't contain a 0. So the answer is A. The value of that expression when x equals 4 is, well, you can just sub in x equals 4, or you can factor it out. It's really up to you. What is your comfort level? I'll factor it out. I don't even know if that's going to save any time, but what the heck, right? So here you go. 4x, and be careful, it's not 4x plus 1 in a bracket like that. It's 4x and then plus 1. I'm going to put the 1 all the way on the far side so you don't add it. Factor out a 3x minus 2, and you'll get 4x plus 1, and you'll get minus 4x. And then you have a 1 all the way over there. So this becomes 3x minus 2, and then the 4x's go, and you're just left with a positive 1, like that. And then now you can enter the value of x as 4. So you got 3 times 4 minus 2 plus 1. So 3 times 4 is 12. 12 minus 2 is 10. And then add this 1 and you get 11. So number 2, the answer is D. How many positive integers n make that a prime number? N squared minus 3n plus 2. This can be factored, correct? n, 2, 1, negative, negative. And as you can clearly see here, this is the product of 2 consecutive numbers. And 2 consecutive numbers, one will always be odd, and the other one will be even. The order might be reversed, it might be even, odd, but they will always 2 consecutive numbers. One will be odd, one will be even. And if you take the product of an even and an odd, the result is what? Is it even or odd? It's even. And you can do that, and, just to verify it, take an odd number like 7, multiply it by 8, 56 is the answer, which is of course even. So this is at the heart of this question. You have to take an odd number, any number, and you have to multiply it by even number. And those 2 numbers are consecutive. One is n minus 1, one is n minus 2. And the result is always going to be even. But they want the result to be a prime number. And all prime numbers are odd. Correct? Yes or no? All prime numbers are odd. Is that statement correct? It's sort of correct. The answer is no, because there's one prime number that is even. and that is 2. Every other prime number, all other primes, are odd. So the only way you can get this to work is if you get the answer to be 2. That's our only even prime number. So how do we get this to be 2? You let n equal 3. If n is 3, you'll get 3 minus 2, which is 1. 3 minus 1, which is 2. And therefore 1 times 2 is 2. So there's only one possible n, and that was when n is 3. You get a solution of 2, and 2 is a prime number. For everything else, you'll get more even numbers, and none of those will ever be primes. And that's a very important topic on math contests, that 2 is the only even prime number. All other prime numbers are odd. So number 3, the answer is B. Let n be a positive integer such that 1/2 plus 1/3 plus 1/7 plus 1 over n is an integer. Which of the following statements is not true? So let's add all this up and see what we can get. So of course, common denominator, 2 times 3 times 7 times n probably. So that's what, 6 times 7, 42, 42n, because these are all prime numbers. All right, common denominator, here we go. This is going to be 3 times 7 times n plus 2 times 7 times n plus 2 times 3 times n, like that. So this becomes 21n plus 14n plus 6n. And I forgot this one. Plus 2 times 3 times 7, like that. Plus 42. All over 42n. So 21 plus 14 plus 6 is 41 plus 42. All over 42n. And this, if you break it up, will be 41n over 42n plus 42 over 42n, like that. So this becomes 41 over 42 plus 1 over n. And we want this to be an integer. So the only way this can be an integer, and this is really done by inspection, is if n is equal to 42. Because if n is 42, you'll get 41 over 42 plus 1 over 42. And that becomes 42 over 42, which is equal to 1. So n equals 42 is the only way you're going to get this expression to be an integer. Now let's look at what they give us as answer choices. Does 2 divide n? Yes. Does 3 divide n? Yes. 6 divides n? Yes. 7 divides n. N is greater than 84. That is not true. So the answer to number 4 is E. Let V, W, X, Y, and Z be the degree measures of 5 angles of a pentagon. Suppose V is less than W, is less than X, is less than Y, is less than Z, and V, W, X, Y, and Z form an arithmetic sequence. Find the value of X. So find this guy right here in the middle. All right, so we don't really need a diagram. All we need to know is that the sum of the angles of a pentagon are equal to what? I hope you know the answer to that. 540. All right, because a pentagon really can be divided into 3 triangles. And everybody knows, especially by grade 12, that the sum of the angles of a triangle is 180. So since a pentagon is essentially 3 triangles, it's 540. So that basically means that if these are the angles, the degree measures, that they add up to 540. So V plus W plus X plus Y plus Z is equal to 540, like that. And then the next information they give you is that these guys form an arithmetic sequence. So if this is A, V, W will be A plus K, X is A plus 2K, Y is A plus 3K, Z is A plus 4K, like that. Right? That's basically what an arithmetic sequence means. So if you substitute these guys into this equation, you'll get A plus K plus A plus 2K plus A plus 3K plus a plus 4k is equal to 540. And now we can just solve for this. So a, we got 5 a's, and then k plus 2k is 3, plus 3 is 6, plus 4 is 10, plus 10k is equal to 540. And probably can divide through by 5, so we get a plus 2k is equal to 108. And what did they want us to figure out? The value of x. X is right here. This guy right here. A plus 2k is x. That's exactly what we figured out. So they kind of made it easy for us, you know. So that would mean 108, and therefore 5 is D. Suppose that a and b are non-zero real numbers and that the operation x squared plus ax plus b is equal to 0 has solutions a and b. Then the pair ab is. So x squared plus ax plus b is equal to 0. And it has a and b as non-zero real numbers. And the solutions are a and b. So solutions meaning those are the roots. So basically what that means is x minus a times x minus b is equal to 0. So we can set these equal to each other like this. X minus a, x minus b, like that. So we have x squared plus ax plus b is equal to x squared minus xb minus ax plus ab, like that. So that means we can probably factor this out to make it look a little similar to the left side. So we will have minus b minus a x plus ab, like that. And therefore, these coefficients have to match. So this one is the exact same as that, and this one is the exact same as that. All right? So essentially what that means is that a here is the same as that guy. A is the same as minus b over a, or minus b minus a. And then this one is the same as that. So b is the same as ab. All right? So let's start with this one here first. If you divide through by b, you divide both sides by b, you'll get 1 is equal to a. So there we go, we found a. Now substitute a equals 1 into here, and you'll get 1 is equal to minus b minus 1, and therefore b is equal to minus 2. So therefore the pair AB is 1 for a and minus 2 for b. And therefore number 6, the answer is C. The product of 3 consecutive positive integers is 8 times their sum. What is the sum of their squares? So we have 3 consecutive positive integers, n plus 1, n plus 2. And their product, so you're multiplying them, is equal to 8 times their sum. So n plus 1 plus n plus 2. So that's the mathematical equation. So this side here becomes 3n plus 3. We can factor out a 3, and we'll get n plus 1. And this side is n plus 1, n plus 2. So the good news is the n plus 1 cancels on both sides, and we get n times n plus 2 is equal to 24. Now, at this point, I can put everything on one side and do a quadratic, or you can do it by inspection. 2 numbers multiply to 24, and they are 2 apart. If you can do it by inspection, that's great. If you can't, no problem. I'll expand it out like this, and we can factor like that. So we have n, 2 numbers that multiply to give 24, 4 and 6, and then positive, negative, I believe. Yeah. So that means n is equal to 4 or negative 6. It can't be negative 6 because they tell you they're positive integers, so n is 4. Okay, so we got n. Now what do they want us to figure out? The sum of their squares of those three consecutive positive integers. Well, these are our three consecutive positive integers, n plus 1, and n plus 2. So if n is 4, n plus 1 is 5, and n plus 2 is 6. They want the sum of their squares. So 4 squared plus 5 squared plus 6 squared. So this is 16 plus 25 plus 36, and that equals 77. So number 7, the answer is B. Suppose July of year N has 5 Mondays. Which of the following must occur 5 times in August of year N? So let's draw a little calendar for ourselves. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And we have 5 Mondays, right? So the first of the month, let's just make it a Monday. And therefore, every 7 days later, it'll be a Monday. 15, 22nd, 29, like that. And we have 30 and 31. And then we get into the month of August. So we make, obviously, the first of the month is a Thursday. And similarly, every 7th day will be a Thursday, very similar to what we did earlier. So there you go. There's 5 Thursdays, basically. So the answer is D. And if you manipulated this in a little bit different way, like instead of putting the first of the month as Monday, you put the third of the month as Monday, you would find it works out to be the same, that you will get 5 Thursdays. All right. Number 9. A, B, C, and D are positive real numbers such that A, B, C, D form an increasing arithmetic sequence and A, B, D form a geometric sequence, then A over D is. So you have A, B, C, and D, and they form an increasing arithmetic sequence. So we have A plus K, A plus 2K, A plus 3K for our values of A, B, C, D. And then A and B and D form a geometric sequence. So A, AR, AR squared, like that. Okay? So we can do this by inspection. We can just let A equal something, so why not start with 1? And let's use as basic of numbers as possible, so K equals 1, let's say. So this would become 1, 2, 3, and 4. All right? Now remember, these are the exact same as over here. So that means this is 1, this is 2, and this is 4. Do these form a geometric sequence? Yeah, they do. Because R is 2. Because A over AR is 1 over R, and therefore this is 1 over 2. And similarly, AR over AR squared, if you just use those numbers, is 2 over 4, which is 1/2. And AR over AR squared becomes just 1 over R. So R is 2. So this all works out with just basic numbers, 1 and 1, basically. So they want us to figure out A over D. A over D, A, our numerical value is 1, D, our numerical value is 4. So the answer to number 9 is C. How many different integers can be expressed as the sum of 3 distinct members of the set? So what they're saying is you have to choose 3 numbers from that set, add them up, you'll get some value. How many of those values can you get? All right. So our set is 1, 4, 7, 10, 13, 16, and 19, correct? 1, 2, 3, 4, 5, 6, 7 numbers. All right. And we are going to choose 3 distinct members. So 3 numbers that are different. So I'm going to first choose the smallest possible, which are 1, 4, and 7. And if you do that, you'll get a sum of 12. And then I'll choose the largest ones, which is 13 plus 16 plus 19. And that sum is 48. And then let's choose a few more in increasing order, so as I'm going in that direction. 1, 4, 7. Let's choose 1, 4, and 10. That would be probably the next one in terms of increasing order. So that gives you 15. How about 1, 4, and 13? That would give you 18. 1 plus 4 plus 16, and that would give you 21. You get the point. So it looks like it's increasing by 3 every time. So 24 and 27, all the way up to 45 and 48 being the largest. So these are our boundaries. So they want you to count how many of these sums. Well, we can list them all, but it's pretty simple and straightforward that we've got basically 48 as the largest, 12 as the smallest, and you're going up by 3 every time. So if you want to list them all, we can. 30, 33, 36, 39, 42, 45, 48. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 of them. So number 10, the answer is A.